we've talked a little bit about some basic equations and so forth, and quadratics also have basic equations. It's important to know that as we change some of the values within the basic equation for a quadratic relationship, it's going to affect the shape of the parabola. Uh, it's going to affect its shape as well as its position on a graph. So that's what we're really going to explore this year. And that's what's different about this year than what you would have covered last year. So we want to take a look at the basic relationship of a quadratic relationship where it says y is equal to a, which is some value, times x squared plus k. And we'll identify what a, x, and k all are as we go through this. And please be aware that the a value it just represents some number. It could be a whole number, it could be a decimal, it could be a fraction, it could be a positive number, it could be a negative number, it doesn't matter. It's just some number. Okay? And so just very quickly, we want to see what happens to the graph when we change the value of a to a number that is greater than 1, or a number that's bigger than 1. So what we see over here on the right-hand side is we have a graph that represents y is equal to x squared. And x squared represents what we call the parent form of a parabola. Okay? And the parent form of the parabola is the simplest, most unchanged form of a parabola. It hasn't been moved, it has not been stretched, it hasn't been repositioned in any way, shape, or form. It's just simply y is equal to x squared. And y is equal to x squared is the most basic parabola that you can have. But we can also change this parabola. We can change the coefficient. Okay, so for example, in the parent form of the parabola, the a value is actually equal to positive 1. So y is equal to x squared is the same as y is equal to 1 times x squared. But if we change that a value, we change that value and we make it go higher to a number that's bigger than 1, for example, y is equal to 3x squared, what happens? Well, if we take a look at what actually happens, it begins to bend the parabola up. Okay? And if we take a look at y is equal to 10x squared, then what ends up happening is that this parabola becomes even steeper. Okay? And so the larger the number of the a value, the bigger or the greater than 1 that value is, the more stretched and taller the parabola becomes. So therefore, if the a value is greater than 1, okay, the parabola is what we call vertically stretched. So the bigger the a value, the skinnier or the narrower the parabola becomes. And we can also look at it from the opposite direction as well. Okay? What happens if we change the a value to be a number that is less than 1, but still bigger than 0? Okay? So again, in this instance, on the right-hand side, we have the parent form of the parabola. And so we've got graphed, the a is equal to x squared. Okay? But now what we'll do is we'll actually change the a value. So instead of having the a value being positive 1, we're going to change that a value to 0.2. Okay, so again, it's just a number. We're just changing it, and 0.2 is still a positive number, and it's between 0 and 1. So if we go to 0.2, then it's going to look more along the lines of this. Okay, so it's going to become wider. If we take a look at a parabola that's 0.02, again, this is a number that's even smaller than 0.2. Okay, and so if we were to graph that, it would look more like this. Okay, and so the smaller the number, the smaller the a value, so long as it's between 0 and 1, the parabola actually becomes compressed, it becomes squished down. Okay, so if the value of a is less than 1 but bigger than 0, okay, the parabola is said to be compressed. So the smaller the value of a, the wider the parabola becomes. Now, we've both only been looking at where the a value is a positive number. And so what we want to try and do is take a look at what happens if the a value becomes a negative number. So now we'll see what happens when we change the value of a from a positive number to a negative number. And again, we're going to follow most of the same rules. Okay, what we see here is when we have uh, it, uh, the equation y is equal to x squared, which is, again, the parent form, which I can't spell for whatever reason. So this is the parent form of the parabola. Then we see that it opens up. However, if we have y is equal to negative 1x squared, okay, again, this is positive 1x squared up there, but if we have a negative 1x squared, then what we end up seeing is that the parabola is in fact flipped upside down. Okay? It hasn't changed shape at all, it's just changed direction. Okay, and so when the a value is a positive number, the parabola opens up. If the a value is a negative number, the parabola opens down. So what we see here is that when y is equal to negative x squared, the shape of the parabola remains the same. It has not been stretched and it has not been compressed, but it's just simply flipped upside down. If again, however, we change that number, okay, to something other than 1, again, y is equal to negative 5x squared, the negative indicates that it's going to open down. The 5 indicates that it's going to actually be stretched. And so y is equal to negative 5x squared is actually a compressed form of this parabola. Okay? And so therefore, if the a value is less than 0, the parabola is flipped or upside down. But in a sense, you're really looking at the a value and then the sign in front of the a value in two different lights. If the a value is positive, it opens up. If the a value is negative, it opens down. But the number of the a value determines whether or not it's going to be stretched or compressed. So if we try and consolidate that learning together, we see that if a is a number that's greater than 0, okay, then the parabola is opens up. Okay, so it opens up. And if it opens up, it means that it actually has what we call a minimum value. Okay, it has a minimum value. If the a value is less than 0, i.e. it's a negative number, then the parabola opens down. Okay, and if it opens down, then it has a maximum value. See, the vertex is at the top. Okay, if the value of a is bigger than 1, okay, so ignoring the sign, plus or minus, if the number is bigger than 1, then the parabola is stretched. Okay, and it's made thin. Okay, so thin means, or stretched means thin and tall. But if the a value is between 1 and 0, okay, so it's less than 1 but bigger than 0, then it is compressed. Okay, and that means that it's made fat, for lack of a better term. Okay, so the a value will tell you a lot. It will tell you the direction of opening. It will tell you whether or not the parabola has a minimum or maximum value, and it will also tell you whether or not the parabola is stretched, compressed, or if there's no change to the basic shape of the parabola itself.